All right, let's understand Docker actionably, by which I mean how do you use Docker to run packages locally. The motivation for this video is how can you use Docker to start, let's say, MongoDB locally or Postgres locally. Docker lets you do 10 different things. I have a detailed tutorial on YouTube, part 1 and part 2, that will take you through how you can use Docker. If you want, you can go through these tutorials. We will be covering these in 1 to 100 as well. So you don't necessarily have to go through these for this one. These are not a prerequisite for this video. This video is understanding Docker from the top, specifically how can you use Docker to run packages locally. What do I mean by packages? Things like Mongo, things like Postgres, which have very hard installation processes. If I search for how to install Postgres locally, there's like a detailed, blog post. I can go through this GUI and set it up, or you can use Docker. In a single command, it'll let you run various packages. As time goes by, these aren't the only two databases you might need. You might need other packages in your backend development journey. So for that, it's good to, just use Docker and run a single command and bring them, rather than, going through the steps and bringing it on your machine. Cool. This is an actionable Docker tutorial to start packages locally. It's not Docker in depth. These two are Docker in depth. We'll also be covering Docker in depth later on. First step is installing Docker. Spend time here and do not move from this slide unless you've actually installed Docker. There are a few ways to do it. Docker GUI is the easiest one. So if I search for Docker here on my machine, it'll open this GUI if time allows us to. If not, we'll just wait. There you go. Go to dashboard. A GUI that looks something like this, Docker desktop. So you don't necessarily need to do the fanciest thing and installed only CLI. You can go here, search for the operating system that you want to install it on. For example, I wanted to install it on Mac OS. And so all I did was install Docker using Docker desktop. I clicked here, I downloaded the file, I went through the installation steps and installed it. You can, based on your operating system, decide how you want to install Docker. I'm not going through the detailed steps to do it, but the way you know it's working for you locally is if you open a terminal and if you're able to run the command Docker and you see some output and the output does not say Docker command does not exist, or if you want to test it even more heavily, try running this command Docker run hello-world. And if you see an output that looks like this, hello from Docker, it means you're good to go. If not, stay on this slide and go through the installation based on your operating system. Google a bit. It's not too difficult, but sometimes, especially if you're on Windows, I'm sure you will run into some issue. So try chewing some glass on this slide and only proceed from here if you have this command working correctly. If not, just pause here. Try it out. Does not happen. If you see some very weird error, Google doesn't help you, then ask a TA and they'll help you install Docker locally. All right. With that, after you know Docker is working, let's understand what are we using Docker for today. Docker lets you do a lot of things. It lets you what is called containerize your application. I'll take you through what this is. It lets you run other people's code plus packages on your machine. It lets you run common software packages inside a container. The same thing I discussed here. For example, Mongo, Postgres, etc. So before we understand Docker, you should understand another concept called containers. Again, this is in detail covered in this video right here, but let me take you through a very high level introduction to containers. If this is my Mac machine, I can either run someone else's code directly here, which means if I open my terminal, and if I run node index.js in a specific folder, that's me running, let's say, my own code if index.js is written by me, or someone else's code if this is written by someone else locally on my machine. That is one way. Similarly, I can run MongoDB. If I install MongoDB using the official method, then I have to run this specific command MongoDB on my machine to start it. And this is me running things natively on my machine, which means I'm running node index.js or Python a.py or cargo run xyz or go build a.go, so on and so forth. I can run these Go files, Rust files, Python files natively, or I can run them inside a container. What does a container mean, Harkirat? It means that thing, if I run, let's say, an index.js file inside a container that is running in its own mini computer. You can think of a container as a mini computer that is running inside your computer. This mini computer has its own file system. It has its own what's called network. And if you run, an index.js file inside, that index.js file runs here in this container, but your Mac machine doesn't care about it. If I start node index.js, which is, let's say, a express application inside a container, and the express application is listening on port 3000, then this mini machine is listening on port 3000, but my Mac is not listening on 3000. I repeat, this part is important. If I start an index.js file inside a container, and if I go to localhost :3000, this request will not, I repeat, will not reach this container. This request will be like, nothing is running on 3000, because nothing is running on my Mac on 3000. Something is running on another computer, or like another mini computer on my Mac, but nothing is running on 3000. That is what container lets you do. It lets you isolate all the code. Okay, bhai, this code is running, but it is running independently. It is running inside your big machine in a small machine. If someone goes to localhost :3000, nothing is running on this Mac. On this Mac, I can still run node index.js independently. And then this index.js can listen on 3000. And then this request can go here, even though there is a mini computer running that has something running on its own 3000. So Harkirat, does it mean my container has its own ports? Yes, you could say that. Your container has its own set of ports and you can run things there independently. Your container has its own file system, which means it has a root folder where index.js might be, which is different from the index.js that is in the root folder of my machine. If I open my terminal, you see an index.js file here in my root folder. This index.js is different from if I start a container, it has its own index.js. So what have we learned? Okay, containers is a concept which lets you start. You start a container, you're starting a small machine on your big Mac machine, and then that has its own file system, that has its own network. And if you want, you can route requests coming on the machine on port 3000 to the container. If you want, you can do this. That's how, it would actually make sense to start a Node.js application on port 3000. Otherwise, what's the point of even starting it if I cannot access it on 3000? If you want, you can take your Mac's network and say, okay, bhai, any request that's coming on my Mac on port 3000, please go to this container. But if you want, you can also say, okay, bhai, it is running independently. I will not allow anyone to access this container. Cool. So quick recap of what have we learned. The thing we've learned is, okay, Docker lets you create something called containers, which are nothing but mini machines with their own network and file system. Why is this useful today? The reason this is useful today is because what I'm telling you is, okay, bhai, if you want to bring MongoDB locally, don't go through the standard route of, installing MongoDB on, using the GUI or whatever instructions you might get. I am saying just run a single command that will start a container that starts MongoDB. I repeat, throughout this tutorial, what we are trying is, okay, you're able to start MongoDB or even Postgres for that matter, locally on your machine inside a container. So you will start a container where Postgres will be running on port 5432, or you will start a MongoDB container where MongoDB will be running on port 27017. And if you want, as I said, you can say, okay, any request coming on localhost :5432, please go to this container. And same is true for MongoDB. You can be like, any request that's coming on 27017, please go to this container. That is what we'll try to do. We will start containers of Postgres, of Mongo using Docker, and we will tell, okay, the Postgres container that is started, any request that's coming on my Mac on 5432, please go here. Any request that's coming on my Mac on 27017, please go here. That's a lot of talk. Let's write some code. Let's see how. Number one, Docker lets you create containers. Number two, Docker lets you map a port from your machine to a container so that any request that's coming on 5432 here goes to the port 5432 on this mini machine. Let's look at the slides. I hope you understand what are containers by now. On my Big Mac machine, I can start a small MongoDB container, a Postgres container. I can also start a Node.js application. These can be multiple mini machines that run on my Big Mac machine. We look at the command that lets you do it. The next slide says, where can I get packages from? I said you can bring Postgres locally and MongoDB locally. Maybe ignore this for now. Where does this come from? Like, do I go to some MongoDB.com and do I get the container from here? Where can I find the code that actually starts a container of be it MongoDB or be it Postgres? And the answer is, just like you can push your code to GitHub and GitLab, you can push what are called images to Docker registries. So another thing I'm introducing here called images. What is an image? Basically, anyone who wants to, put their package out in the world for other people to run, be it Postgres, be it MongoDB, whoever wants that other people can run these containers, first creates an image. I repeat, they first create an image. Okay, bhai, this is the MongoDB image. It has the code of Mongo. It has, a few dependencies like C++ that Mongo needs. It has Python as a dependency because Python and C++ are something, let's say, that Mongo need. Theoretically, I don't know if Mongo actually needs them, but let's say if you want to start the MongoDB database, you will need C++ and Python. So I package this all together and create an image which has Python, which has C++, which has Mongo. Think of this as the CD drive that your friend gives you if you want to ever install Windows. If this is your Mac, this is your machine, not even a Mac machine, this is your native machine, and let's say it does not have Ubuntu in it yet or does not have Windows in it yet, you get a CD or a pen drive from a friend and then you put it in your machine and that starts Windows. The thing that's present in this CD is what you can call an image. Whenever you want to get not just some code, but actual operating system code, the actual package that runs not just some code, but also gives you the GUI, 10 different things. You get it in a CD from a friend, or you guys might even know what CD is. Pen drive from a friend, if you guys know what a pen drive is, or I don't know how people exchange operating systems today, but back in the day, you would get it in, I guess, a pen drive, or a hard drive is a better way to say it. You would get a .iso file if you've heard of it. Even today, if you've tried to install Ubuntu, you might get a .iso file from a friend and then, put it in your machine, start Ubuntu. And similarly, if you want to start MongoDB, you will get an image from somewhere. An image is nothing but a lot of code which has your file system, which has all the dependencies that are needed to actually start MongoDB. Similarly, here, if you want to ever install Ubuntu, the image has all the necessary things to be able to start that operating system on your machine. So where can I get these packages from? If I want to start a MongoDB container, where can I get it from? You can get it from what are called registries. There are many, just like there is GitHub, there is GitLab, there is Bitbucket, there are various places you can push your code. Similarly, there are various places where you can get these images from. Docker Hub is the most popular one. So if I just search Docker Hub Mongo, you will see I reach a page like this, which is very similar to, GitHub MongoDB. What does this GitHub page contain? It contains all the code of MongoDB. What does this Docker Hub page contain? It contains the image of MongoDB. It contains, I have the code, the file system, the dependencies. I have everything you need to start MongoDB locally. All you have to do is run a single command and pull me onto your machine. I will start a container. So an image is something you can get from the internet. If this is my Mac machine, then eventually I want to start Mongo locally. What I will do is I will bring this image locally onto my machine and then run this image, which will actually start my container, the Mongo container. So effectively, what is a container? A container is nothing but an image in execution. Just how you get a file from your friend if you want to install Ubuntu, then you start it on your machine, and then you have Ubuntu running. Similarly, you can get an image from dockerhub.com or another registry. And once you get it, when you start it locally is when you can say you have started a container. That's the difference between a container and an image. An image is, you can think of an image being all of this code that exists on GitHub. And you can think of the container as if I pull this code on my machine and start it. That is what a container is. So an image in execution is what's called a container. Cool. Hopefully we understand the difference between an image and a container, and how when you want to start a container locally, you have to first fetch an image, which you can get either from there are multiple registries just like GitHub and GitLab compete. Docker Hub and AWS registry and Google registry, they all compete. There are various places you can publish your code. Docker Hub is the most popular one because this is owned by the same company that has created the Docker software. This is the page for the MongoDB code if I want to bring and start MongoDB locally. Similarly, I can search for Postgres Docker image and it will give me this page which has the official image of Postgres. So if I want to ever start Postgres locally, I will get it from here. If I ever want to start Mongo locally, I will get it from here. Cool. Now the question is, I understand image exists, Harkirat. I understand Docker lets you start containers. How do I actually start a container? Good question. Let's see that next. The common commands to know if you want to start containers locally. There are 3 common commands that you will run with. Again, at this point, make sure Docker exists as a command and you're able to run, Docker on your machine locally. I'm going to put this on the side and then take this on the other side. All right. The first command to know is Docker run. If I want to start MongoDB locally, the command that I run is as simple as Docker run and the name of the file or the name where it is stored on Docker Hub, which in this case is Mongo. So if I run Docker run Mongo, you will see a bunch of logs appear. These are the same logs that will appear if you start Mongo on your machine without using Docker. This is just the standard logs that come when you're starting MongoDB locally. And that is it. This is the only command that you had to run to start MongoDB locally. You did not have to go through any installation procedures. You don't have to go through a GUI. You simply ran a command and Docker pulled this image from Docker Hub and started it locally. You might ask, Harkirat, it happened so quickly. And that's because I've already run this. So I already had this image on my machine. If you run this command for the first time, you will see it takes some time. It will also give you a log that says pulling the image. And once it pulls the image, it will start the software for you immediately. What have I done when I've run this command? I have done this. This was my Mac machine. I have started a container which is running Mongo, and by default Mongo runs on what port? It runs on 27017, which means I have a Mongo instance running on my machine. It is also listening on port 27017, but on itself, the thing that I discussed initially, okay, this has its own ports, this has its own network, and right now it is running something on its own network. If I open MongoDB Compass and if I try to connect to, the standard MongoDB localhost 27017, it says connection refused. Harkirat, you said you started Docker, but MongoDB Compass isn't able to connect to it. Why? Because as I said, I have not yet said that my Mac machine, pay for something comes on 27017, it should go here. I have not yet added a port mapping. I have not yet told. I've started Mongo. I have Mongo running, but it's inaccessible. No one can access this Mongo. It's just running independently. If you want to actually allow any request that's coming on this Mac machine, please go here and get routed to the port 27017 here. You have to run another command. We'll see what that is. Let me exit out from here. And now I have nothing running on my machine. I have no Docker images running. Let's go back to the slides and see what it says. When I started the command, I started a container where it's running 27017 or listening on 27017 on itself. It has not yet accepting requests on the Mac machine. You will notice that you can't open it in MongoDB Compass. If I open it here, it says connection refused, cannot access on 27017. Adding a port mapping. If you want any request that's coming on your Mac on 27017 gets routed to this container's 27017 port, this is the command that you run. You say docker run and port mapping. Any request that comes on the Mac on 27017, please go to 27017 on the container. Now if you run this command, then any request that's coming on the Mac on 27017 will get routed here, which is why if I now open MongoDB Compass, if I click on connect, you will see I am let in because now I am running Docker locally, Mongo locally, and I've also opened a port mapping. I've also said, okay, any request that's coming on 27017 on my Mac, please go here. Harkirat, what happens if I change this to 27015, let's say? Great question. Now, if I open MongoDB Compass, what do you think the URL should be? I'm saying any request that's coming on 27015 should go to 27017, which means if I go here, I need to replace this with 27015 because now I say MacPay whenever something comes on 27015, then it goes to the containers 27017. So unless I replace this with 27015, there's nothing running on any other port, right? Now it will work. If I try to connect it to 2715, if I try to connect with this port mapping to 27017, it will fail. Let me show that really quickly as well. If I try to connect, it says error. If I change the port mapping back to 27017 and try to connect, it just works. Cool. That's the easiest way to understand how you can bring packages locally. Again, Docker lets you do 10 different things. We're using it for a very simple thing to, run packages locally. One extra thing to know is if you want to run it in the background, by which I mean, if you want to just, run it and not see any logs, have it run in the background, you can run it in detached mode, which means add the -d argument. If I run this, you will see it exits out immediately. It is still running on my machine. I can confirm that by running docker ps, which is basically show me all the images that are currently running or the containers that are currently running. So if I run docker ps, it shows me I'm running this one machine, this one me machine, this one container. This is the port mapping. It has been up for 6 seconds. It was created 7 seconds ago. This was the command that was used to start it. This is the image that it is running, so on and so forth. This is the ID for this container. What was the command that I ran? Docker run in detached mode with this port mapping, the Mongo container. And how do I see all of this? By running docker ps. This is the second command that I wanted to show. And the last command was how to kill a container. Now, let's say you're done with your process. You don't want to, use Mongo anymore. Then you can simply stop Docker by docker kill and then this. And this will kill the Docker container, which means Mongo is no longer running. Nothing is no longer listening. If I run docker ps again, nothing is running. You're good to go. Cool. These are the easiest ways to start any project locally. If you want to start Postgres next, it's as simple as, this was the command for Mongo. This is the command for Postgres. It has something extra. I'll show you what that is. Let me copy this and paste this here. What does it say? It says docker run -e, which basically means environment variable, Postgres password equal to something, and then everything else is the same. Detached mode, port mapping 5432 to 5432 Postgres. This is the image name. This is what I pull from Docker Hub. Detached mode and port mapping, since Postgres by default runs on 5432, it is running on 5432 inside the container. I add the port mapping for it to run on 5432 outside. The only extra thing is this. I added an environment variable, which is Postgres _password, which I gave some random password. You can give it whatever password. What is this environment variable? Now, when you are starting Postgres locally, it might be good for you to give it a password. You also can work without it and not give it a password, but you ideally want to secure the, by default, it will probably give you another password. It's not like if I don't pass this environment variable, it will not have a default password. It will probably have a default password, but it might be good for you to inject a password. Ki, haan, bhai, when you start when you start Postgres, this is the password that you can use, so that if I run this and try to connect to it, this is the connection string that I have to use. This is how I can connect to my Postgres machine. And notice the password here, which is the thing that I passed as an environment variable. Harkirat, how will I find what environment variable to pass? Good question. You will basically go to Postgres Docker image, and here it clearly shows you that you can use this. But if you want, you can actually inspect the Docker file of Postgres. Not going there, but okay. It's very easy for you to figure out that this environment variable, if I use, for example, in this case, Postgres password, it would mean this in the context of Postgres or the container that is being started. Ki, haan, if I pass this in, then the container that is starting has this password. So the connection string finally becomes my super secret password. Harkirat, how did you figure out the username? How did you figure out the table to connect to? By default, Postgres, if I again search for Postgres Docker image, by default, the connection string that it gives you, or like the username and password that it puts, is Postgres. For example, here you can see Docker run Postgres. Let's see if we can find. Okay, there you go. This is where you could see the environment variables that you can put. I just put Postgres password, but you can also put Postgres username, and it'll probably say here, default user